Hello, welcome to uh, the open elective class on basics of aeronautical engineering. I am Dr. Ilangovan, professor from the Department of Aerospace, and today we are going to look at the various parts of aircraft, and this will be the first part of the two uh, two numbers of PPT. The airplane parts are given here in this drawing. I am definitely taking help of materials that are there available on this, and I should thank both NASA and Glenn Research Center for me to taking all the material from the internet. Okay, so here we have the various parts listed out here. We have the horizontal stabilizer, we have the vertical stabilizer. We have a small moving part here which is called the rudder, which changes yaw to slide side to side. And then we have an elevator here to change the pitch up and down. We have the flaps on the wings to change the lift and the drag. We have the aileron to change the roll when the flight wants to take a turn. We also have the spoiler to change the lift, drag, and the roll. Together we have a small spoiler here. Then we have the slats in front of the front part of the wings, and which changes the lift. The fuselage is the entire body on which the passengers travel. Basically, they hold things together and carry the payload. We have the cockpit or the command and control cabin meant for the pilot, and the jet engines are on the either side. The wings are there to generate the lift, and so this is an overall understanding of the parts of the aircraft. Now, wing is a type of fin that produces a lift while moving through the air or some other fluid. So we have a wing here, we have a wing shown here, and it's made out of sheet metal. Accordingly, wings have streamlined cross sections that are subject to aerodynamic forces and act as airfoils. Its efficiency depends on the lift to drag ratio. So different cross sections or different shapes are available, and the best one is chosen during the design phase. The lift of a wing generates at a given speed, and the angle of attack can be one or two orders of magnitude greater than the total drag of the wing. A high, a high lift to drag ratio requires generally a small thrust to propel the wings through the air at sufficient lift. This is the wing shown, and you have the aileron here, the flap is here. These are the spoilers to add drag. Then you have the slats on the other side, and and then you have the flats also. So, why do airplanes need stabilizers? Airplanes are exposed to fast-moving winds during flight, which can affect their maneuverability. Fortunately, they feature aerodynamic surfaces like stabilizers to provide control and stability. You see this elevators and the stabilizers. Stabilizers will stabilize the airplane during the flight so that the pilots can safely and effectively maneuver it. Now, a horizontal stabilizer is used to maintain the aircraft in the longitudinal balance or trim, as it exerts a vertical force at a distance so that the summation of the pitch moments about the center of gravity is zero. Okay, so trimming is like trying to reduce it or increase it, kind of stuff. Adjustable stabilizer also there. You see here the stabilizer can move up and down over a jack screw. So you want the nose down or nose up, and then the trim motor can trim the cable. Adjustable stabilizers are not the same as stabilators. A, steb, a stabilator is controlled by the pilot's control yoke or stick, whereas an adjustable stabilizer is controlled by the trim system. In Boeing 377, an adjustable stabilizer trim system is empowered by an electrically operated motor. The rudder, okay, rudder is located on the vertical stabilizer. It controls the aircraft's yaw. Yaw is moving sideways. We have the right rudder yaw. We also have the left rudder yaw. Okay, so this is again on real aircraft. This is controlled by foot pedals. When the pilot pushes the left pedal, the rudder deflects to the left, and pushing the right pedal will cause the right rudder to deflect. Okay, so next we move on to the elevators. The elevators are flight control surfaces, usually at the rear of the aircraft, which the control which control the aircraft's pitch and therefore the angle of attack and the lift of the wing. The elevators are usually hinged to the uh, tail plane or the horizontal stabilizer. They may be the only pitch control surface present and are sometimes located at the front of the aircraft or integrated into a rear all-moving tailplane, also called as the slab elevator or the stabilator. Both horizontal stabilizer and the elevator contribute to the pitch stability, but only the elevators provide the pitch control. So they do so by decreasing the or increasing the downward force created by the stabilizer. An increased downward force produced by up elevator forces the tail to go down and the nose to go up. At constant speed, the wings increase the angle of attack and causes a greater lift to be produced by the wing, accelerating the aircraft upwards. Upwards. The drag and the um, power demand also increase. A decreased downward force at the tail produces a down elevator and causes the tail to rise and the nose to lower. At constant speed, the decrease in the angle of attack reduces the lift and accelerating the aircraft downwards. The vertical stabilizer along with the horizontal stabilizer makes up the entire thing is called as the empennage. Um, the vertical stabilizer is equipped with a movable rudder, which gives the pilot a yaw control, the ability to turn the airplane left and right. Some of the vertical stabilizers are also fitted with trim control, providing the ability to make finer adjustments according to the information from NASA. Now, the final question here is like, why don't bird need uh, the stabilizer or the rudder? Birds have infinitely controllable, adaptable, and flexible wings that can produce yaw control through adjustments to shape, span, and sweep, and so hence they don't require the rudder. So, with this, we will close this first part of the aircraft components talk, and we will resume again on the next one. Thank you very much. We'll meet once again. Thank you.